Well, now we're going to solve equations using the square root property where we can have irrational roots. And so let's look at this first equation that we're presented with. It says x squared plus 8x plus 16 equals 20. Now, if in looking at this part of the equation here, we see that, well, this is a perfect square. I've got x squared over here on the left, and I've got 16 here on the right, positive 16. I've got a positive middle term, and that's 8. And let's see, perfect square, the square root of 16 is 4. And so I could write this left side of the equation as x plus 4 times x plus 4 equals 20. And then I could continue to write this as x plus 4 squared, x plus 4 times x plus 4, that's x squared, equals 20. And then using the square root property, we can take the square root of both sides. So here we would have the square root of x plus, I need to put this in parentheses, plus 4 squared equals the square root of 20. All right, well then the square root and the x squared over here on the left cancel, and that leaves me with x plus 4 equals the square root of 20. And I'm going to hop on my calculator here and find out what the square root of 20 is. So let's see, square root of 20. And I'm going to round that to the nearest 100th. And this I should put plus or minus in here. So we got x plus 4 equals plus or minus 4.47. And then we can solve this equation with the plus and the minus. And so let's see here. Let's start off with x. Let me change colors on this. On this white, let's go to green. All right, so we got x plus 4 equals positive 4.47. Okay, and we're going to subtract 4 from both sides. And when we do, let's see, 4.47 minus 4 is going to give me 0.47. And let's see, let's solve the other half of this, where we've got x plus 4 equals negative 4.47. And now we're going to subtract 4 from both sides of the equation once again. And let's see, negative 4.47 minus 4, well then x is going to equal negative 8.47. And so my two irrational roots in this equation then are, let's just put that in a little bracket, sloppy looking bracket. Well, let's just use parentheses, why not? So our two then solutions then are 0.47 and negative 8.47. And those are our roots, those are our zeros, those are our solutions, those would be our x-intercepts of this equation that has given us irrational roots where we use the square root property. And I think we should probably solve one more. What do you think? Let's do. All right, so here we got x squared minus 6x plus 9 equals 32. And again, on this left side of the equation, I see again that I've got perfect squares. I got x squared plus 9, but this time my middle term is negative. So I can then say that this is factoring this x squared minus 6x plus 9. This is x minus 3 times x minus 3 equals 32. And again, I could rewrite this as x minus 3 squared, being careful to put it in parentheses, equals 32. And then we're going to take the square root of both sides, x minus 3 squared, square root of that equals the square root of 32. And the square root of the binomial squared is going to cancel. It's going to leave me with x minus 3 equals the square root of 32. And I probably need a calculator again to figure that. So let's see. Square root of 32, enter, equals, you can't see it. Well, it equals 5 point, rounding to the nearest hundredth, 66. So that equals 5.66 plus or minus. And I should put plus or minus up here. All right, well, let's take these and let's solve them. So I've got x minus 3 equals positive 5.66. I'm going to add 3 to both sides. So I got x equals 8.66. That's half of my root. That's one of my roots, one of my irrational roots. And let's do the other. Now I've got x equals, excuse me, I should put minus 3. X minus 3 equals negative 5.66. And we're going to again add 3 to both sides. And once we do, x is going to be equal to negative 5.66 plus 3 is going to be negative 2.66. And so my two irrational roots of this equation, x squared minus 6x plus 9 equals 32, using the square root property, are negative 2.66 and 8.66. All right, solving equations with irrational roots using the square root property. Next, we're going to move over to something called completing the square.